Hi, welcome to Resolve Chemistry. Let us continue our discussion on this chemical kinetics. In the previous video, we have discussed derivation of integrated rate equation for zero order and integrated rate equation for first order reaction in separate videos. In the present video, we will discuss a half-life period means what, and what is the half-life period for zero order reaction and what is the half-life period for first order reaction. Let us see that. Okay. So first we will define what is half-life period means what. So that is also represented as T half, or it is also represented as T 50%, like that we are going to represent. Okay, so what is the lifespan of a human being, okay, which is being average, which is being considered. So it used to be 100, so then half-life will be what? 50 years. Okay, like that, the initial concentration when you take of any reactant, so how much time it will take to reduce to half? Say for example, I have taken 1 mole. Okay. So how much time it is required to convert that 1 mole of reactant, half of the initial concentration of the reactant. Okay. So let us define that one. Okay. So now for example, you can consider a reaction. A gives product. Okay. And this reaction, what you call is T is equal to 0 means the concentration will be A naught, and when time T is equal to T half, meaning is what? Half-life period, what we call. So then what happens? Your concentration will be what? AT we call, and this AT will be what? A naught by 2. Am I right or wrong? Because what we have defined half-life period means the time taken by the reaction to reduce its concentration by half. Okay, whatever the initial concentration you have taken, okay, that initial concentration, how much time it will take to complete half of the reaction, or half of the concentration get consumed into product. Okay, so we will see that one. Okay, so now for zero order reaction, you see here, what is the rate equation, integrated rate equation for zero order reaction? Already we have derived. Please go through our previous video where I have discussed that how this integrated rate equation is obtained. Okay, so that is K is equal to A naught minus AT by T. T is equal to T half we will write, and AT is equal to A naught by 2. So then what it will turn out, we will see that. A naught minus A naught by 2 by T half. Okay. So then you will be ending with what? 2 A naught minus A naught divided by 2 T half. You can T half take on that side. Okay. T half we will take, and we will push the rate constant K on the denominator. So therefore 2 A naught minus 1 A naught. So then you will be getting what? A naught. Initial concentration by 2K. Okay. So this is how the half-life period for zero order reaction we are going to give. And you should remember that the half-life period of the zero order reaction will be what? Dependent upon the initial concentration of the reactant. Okay. So then similarly we will see for a half-life period for the first order reaction. Same, you consider A gives product, and at time T is equal to 0, the concentration of the A is A naught, and when time T is equal to T half, then concentration is AT, that is nothing but A naught by 2. Why I have taken A naught by 2? Because we are considering T half. T half means the initial concentration should reduce to half. So that's why we are taking A naught by 2. Okay. So we will see that one. So now, write the integrated rate equation. T is equal to K, I am taking on that side. 2.303 by K into log A naught by AT. Okay. So this is the integrated rate equation for what? First order reaction. Now what you do? You substitute T as T half. Then your initial concentration at time T is equal to what? A naught by 2. Okay, you substitute these two in the above equation, so then you will be ending with what? T half is equal to 2.303, okay, divided by K into log A naught by 2. So 2 will go onto the top. Okay, so then what you will be getting? 2.303 by K into log 2 into A naught by A naught. So this A naught get cancels, and log 2 value is 0.301. Okay, 301 into 2.303 divided by K. So this is what is your T half. So therefore T half is equal to 0.693, okay, divided by K. When you look into this equation, what you will see, there is no concentration term in the equation, so therefore it is independent of the initial concentration. This you should make sure. Okay, so many problems will be asked on this half-life period of the first order reaction, and for different concentration like T75 they will ask. You should remember that T75 is the double of the T half. Okay, always remember that. Means T half, for example, for any reaction, T half-life period for a first order reaction is, say for example, 1 hour if it is there, then the reaction to complete 75% will be what? 2 hours. Because it is not dependent upon the initial concentration. Okay, so like that you should remember, it is independent of the initial concentration, whereas T half for the zero order reaction is dependent upon the initial concentration of the reactant. Okay, I hope you have understood. Please don't forget to subscribe our channel, and please share with other friends also. Thank you for watching.